Hello everyone. In this video we're going to be solving a problem from JEE Advanced. I don't know which year, but maybe one of the JEE aspirants can tell us which year this problem is from. So we have sine x to the fourth power divided by 2 plus cosine x to the fourth power divided by 3 equals 1/5. And we're going to be solving for x values. Let's go ahead and do the following. We're going to write the cosine x to the fourth power as cosine squared squared. And since we have this famous Pythagorean identity, sine squared and cosine squared add up to 1. So cosine squared can be written as 1 minus sine squared x. Hopefully you know that. If you're doing trigonometry, that's super duper important. Now, we were able to write cosine to the fourth power in terms of sine, but sine to the fourth power is already sine. So let's go ahead and rewrite our equation and also calling sine x s in the meantime. It will save a lot of time and energy if you do this, because sometimes you have to write sine x so many times that it's much more economical to use a letter. Okay, so s stands for sine x. And this gives us the following. We have s to the fourth power divided by 2, which is sine x to the fourth power, plus cosine x to the fourth power. But notice that cosine x to the fourth power was written as 1 minus s squared squared. So we can go ahead and write it like this, 1 minus s squared squared, and that's divided by 3. And the answer is 1/5. So it's kind of like a nice question because 2 plus 3 is 5, but obviously you're not going to add, hopefully, right? You're not going to add the denominators like that. Okay. Let's go ahead and make a common denominator, or we can do the following. It's kind of like the same thing. We can multiply both sides by 30, which is the least common multiple of the denominators. Now, when you distribute to 30, you're going to notice that you're going to get something like this. Let me distribute first, and then I'm going to cross cancel next. I don't want to skip any steps here, but we can do this here. That's going to become 6. Okay, now we got perfect square, 1 minus s squared squared, so that's going to be like a fourth power. But let's go ahead and simplify this first. 2 goes into 30 15 times, and 3 goes into 30 10 times. So the first part is going to give us 15s to the fourth power. And now I'm going to expand this. How do you expand a minus b squared? Remember the formula. It is going to be 1 minus 2s squared plus s to the fourth. That's not my favorite method, by the way, but that's okay. Equals 6. And then I'm going to distribute 15s to the fourth plus 10 minus 20s squared plus 10s to the fourth equals 6. Let's go ahead and combine like terms. These two are like terms. They like each other. So this gives us 25s to the fourth minus 20s squared, right? And then we get plus 10 minus 6, that's going to become plus 4 equals 0. Now, even though this looks like a quartic equation, and it actually is, it is kind of like a biquadratic, which means you can turn this into a quadratic equation by replacing s squared with something. Like, suppose s squared equals u, and then you get 25u squared minus 20u plus 4 equals 0. And obviously, you can solve this using the quadratic formula, right? Wait a minute. What is the quadratic formula? The quadratic formula is negative b plus minus the square root of b squared minus 4ac all over 2a. So if you have a quadratic equation like ax squared plus bx plus c equals 0, then x sub 1, 2 can be found by using this formula, negative b plus minus the square root of b squared minus 4ac all over 2a. Hopefully you memorize this. If you studied algebra, you must have. Now, this is a very helpful formula, and I don't know if you've seen the cubic formula. I think Blackpen Redpen made a video on it, and I might make a video on it later on. But anyways, we use the cubic formula a lot, by the way. I didn't really come up with the formula, but like derivation, we didn't do a video. But so compared to the cubic, it's a lot simpler, So don't hesitate to memorize. And the expression inside the radical is called the discriminant, and the discriminant basically tells us if we have any real roots and how many real roots we have. Stuff like that, because the radical is going to determine, right, if you have a negative number, so on and so forth. Anyways, too much talking, let's get to work. So how do you apply the formula? U equals negative b, which is 20, plus minus the square root of b squared, which is 400, minus 4ac. 4 times 25 times 4 is going to be 400 again. We got 0 inside the parentheses. What happens? What is that supposed to mean? It means you don't need the radical and you only end up with a single solution. And guess what? You only have one real solution because our quadratic, if graphed, would be a parabola that is tangent to the x-axis. So you have something like this. Make sense? Sort of. So that has one solution, one x-intercept. But that's u, right? Okay, great. What is u? U is s squared. So set equal to s squared, you're going to get two values for s because this was quartic, remember? And then we're going to go from there. But you could also do the following. If you recognize these patterns, actually, it's going to be very, very helpful in the long run. So thank me later. When you have an equation like this, and I'm going to actually write the original quartic because it's more fun. And the quadratic will be exact same way. So when you look at an expression like this, one of the things you should always check is, could this trinomial, notice that there are three terms, be a perfect square? And if you could answer that question, perfect. Now look, this is 5s squared squared. This is 2 squared. And their product is 10s squared inside the parentheses, I mean. And if you double that, you get 20s squared. So this fits the pattern a squared minus 2ab plus b squared. And that is a perfect square, and that is perfect. So this expression here is actually 5s squared minus 2 quantity squared. And that's equal to 0 means 5s squared equals 2, s squared equals 2 over 5. And that gets us to the same point, right? But it's much better, and also in the long run, it's going to be beneficial to know these patterns. Anyways, from here we get s equals the square root of 2 over square root of 5, or s equals negative of that. But if you rationalize the denominator, you're going to get root 10 over 5 or negative root 10 over 5 because they're going to be opposites, right? But those are the s values. Are we looking for s? Sure, why not? Well, what is s? S stands for sine x. So let's go ahead and back substitute. So we're going to get two values. Either sine x is equal to root 10 over 5 or negative root 10 over 5. Let's go ahead and solve each of these equations. How do you solve this? There are two solutions. We branch off again. We're thinking about an angle whose sine is root 10 over 5, but that's going to be an acute angle since its sine is positive. If its sine is negative, then you kind of have to think of an angle in the fourth quadrant because the range for the sine inverse function is going to be something like that. Anyways, one of the solutions is going to be sine inverse, the inverse function of sine of root 10 over 5, but you also have to add multiples of 2 pi. The other solution is going to be this one, but this time you kind of have to subtract from pi because if you think about it, if you subtract an angle from pi, which is 180 degrees, then you get an angle whose sine is the same as the original angle. Make sense? First and second quadrant, think about it, you'll get it. Okay, here we go. Now, if sine x is equal to negative root 10 over 5, things are a little slightly bit different. It's better to write it like this. You can basically write sine inverse of negative root 10 over 5, but it's better to write the opposite of sine inverse of root 10 over 5 because it's going to be negative for sure, if you think about it, plus 2k pi. The other one is just going to be pi minus that, but pi minus minus is going to be a plus. So you're going to get this as our fourth set of solutions. And basically, those are going to be all the solutions. Let me kind of zoom out like this so you can see all of them together. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.